Welcome to a new test and teardown video. I think this is going to be a repair attempt or figuring out exactly what is inside this Bang & Olufsen, a Beolab Penta amplifier. They exist in quite a lot of different versions. This one is, I guess, the amplifier, because as you see, there's this special top. And this one is normally not here, and then you have a loudspeaker going all the way up here, and then you have a stand down here, and this is a special stand that looks a lot different from the loudspeaker stands. Unfortunately, this one was already thrown in a container as trash, and there is a error report, and it was sent for service, and they gave up and whatnot, so obviously it couldn't be repaired for the amount of money and time that was allowed for this. And this is how you access the control panel for the amplifier. You can of course turn it on and off, and auto and link, and you can only control the bass, and treble, I guess, by 3 levels, right? So that's how it is. I think that is actually quite alright, so all your speakers will play exactly the same volume if you put them in the same position, right? So that's not too bad. But first we need to figure out how to open this thing, and as you can see, it's not that easy because you don't see any screws, but I've been cheating a little bit. It is possible to find manuals here and such. And by the way, this amplifier should be able to do 300 watts of music watts, or 150 watts of continuous sine wave power into 8 ohms. So I mean, it is definitely worth a saving for all sorts of cool projects. So a quite beefy power amp. So this is the special stand for the standalone amplifier. I'm taking that one off, and this way we get access to the 5 nuts down here, and that will give us more access. Yeah, definitely. That will be the external speaker amp level input. So you got line input or amplifier level. What is that? So there's a short circuit here. Really? Let's see if we can get more in here. So that was the 5 nuts, and some of them actually come out like all the way. Let's just, yeah, okay, they're totally loose. So we're definitely gonna go in here in a few seconds. And by the way, to people who throw things they want to throw out, you know, I think you're revealing some sort of a mental disease or illness when you're doing that. So please stop that and just put things nice, calmly, slowly into the trash container, because there will come a little trash rat like me or some of my friends and pick up the goodies and play with it just for their pure enjoyment. By the way, there's a little screw here in this cover here. By lifting this up, you get access to mange fuses, and this is of course what you need to check first. So far so good. This looks quite alright. We don't have any cracks. And by the way, by removing those 5 bolts, it is now time to flip this upside down, and then we can access the top. So that's the 4 long bolts that goes all the way through up to this top unit. And like I said, this is a special top cover, So you can use this amplifier as a standalone amplifier. Normally it's looking like this, and this is where your speaker goes. This is the output cable that goes directly up to your speakers. So with this top plate removed, now we can see the transformer, and that is a very, look at that. It is a very, very big and sexy transformer. I mean, if everything else goes wrong here, you want to save this one for your future hi-fi DIY project. Definitely a good score. So, boy, this is big and beefy. Good. So we're going to take that one out. Oh, by the way, the idle power of this transformer is less than 5 watts. So that tells me it's super high quality. I think my idle power assumption I just said 10 seconds ago, that was wrong. Because look, there's another mains transformer here on the back of this assembly. So that's the big bad boy. And then there's a tiny one. And this is obviously for idle. And then there is a main power on relay. So it's monitoring in auto mode. It's monitoring the input. And if there is any input, then it's powering up. And then, so this is obviously a remote located active speaker amplifier, right? But you can also have it in on or in link. So that means it's powering on via a link input, but we want it to be in auto, right? So now this big bad boy here is open. Let's see if we can get some light in here. I mean, I need to see if I can remove all those cables, and there will be some connectors, and how can I get all the way in here? But you see the nice green PNP transistors. That's Japanese style of so that is all the negative rail transistors, and that's all the positive rail transistors. I bet that is a pre-driver, and that will be the 3 output stage transistors. And again here, well, that is really a beautiful design. It's quite compact, and of course a pain in the butt to service, because how can I power this up and how can I access everything? It's just going to be like this, and it looks like, I don't know, electronic vomit all over the table here. Man, it's a little bit funky here. But let me see if I can access. Maybe I can take out that other plastic cover and access that PCB from the other side. That would make me quite happy, so I can measure and see what's going on here. Great. Right under the mains input, there was this extra isolation pad here, and that's quite good. But then I see this resistors, 2 resistors in some heat shrink, and they look a little bit burnt and melted. And I suppose it was connected somewhere for maybe minimum load on the output in case you power this up without a speaker on. I don't know, that's just my guess, because the wires was not connected to anything. So that will be the 2 different mains input for the little transformer and the big one, right? So those wires, they go here, and they go to the transformer assembly. And then all the other wires, they actually go into connectors, as you can see here and here. So that means we will be able to take out the PCB in case we unflip all the transistor clips, and then unscrew the PCB and detach all those connectors. I mean, yeah, you could actually take out the PCB, but why would you need to take it out? Because we can actually service everything from both sides. See, I can access the entire PCB here. It's of course a little bit annoying with the very short cables between these two parts. So it's, you know, I need to play surgery here to get in here. And let's take off the flying parts here. I just want to be sure that I have a picture of where it's soldered in the one end. So that will be the two resistors. And it's a little bit funny. It says R10 and then a K. That is confusing, isn't it? I don't really like that K here. So of course I'm measuring them, and there's 0.1 ohm each. So what the heck is that a series resistor in series with the speaker output? So that means it's not playing anything because that resistor is not connected. I mean, could it really be that easy? Because it's connected to that point down here. And why are you so stupid, this camera? Here we go. Come, no man. But where's the other point? I got no clue, man. This is annoying. Alright, I think I'm actually ready to do a power-up test. I've inspected everything. I've been testing the transistors in circuit and all that kind of stuff. And it appears like it's not that bad, really. So I feel I'm kind of ready. I added a little light bulb here on the output. Input is connected to my signal generator, so I can turn this on and off if I want to. And yeah, I feel we just plug in. I put it in off. Mains connector goes in. You're gonna hear a little no kaboom. So I will put this in auto. And no cigar. Oops, not even that. That's interesting. All right, let's investigate. I actually was very sure that I checked the fuses, and now the small one is blown. That was only 40 milliamps for the standby. So I put in 100 milliamps, and let's hope it was just unlucky. Well, let's try and do this again. Mains is in, and let's put this in auto so it's gonna go straight on, right? And cap poof. $42 watts. And no light. Why is it using 42 watts? I have to turn this off immediately. Okay, time for the thermal camera, and let's have fun. Doing again, I'm super cheating with the thermal camera. I just gave it like 80 volts of mains voltage. So it's only 5 watts at this low power, or this low voltage. And of course, all this low voltage stuff. See, there's a rectifier. We got some little diodes down there, I think. And we got capacitors and the voltage regulators and stuff. So that is, of course, where we are going to look. Because I believe all this kind of stuff is coming from the little idle transformer. And look what we got. We got hot stuff. Yeah. So I don't really see any other hot parts. So here we go. All I have to do is now see exactly what it is, and I believe it's the rectifier. Ha ha ha. Oh, thermal cameras just wins. It's just the lazy man's tool. That's what it is. Yes. So, look what I'm doing here on the thermal camera. Look, I'm holding in a cotton bud in front of something right here, right? So if I remove the thermal camera, and let's have a look. What is it I am looking at? Here you go. That one down here is the bridge rectifier. That one, I am holding the cotton bud on top of that one. Why is it so out of focus. So that one we need to remove. It's that easy. So that was the bridge D1. And I just measured this with my multimeter and all 4 diodes seems to be working. But so how is this one getting very, very warm? And nothing else seems to be getting warm. This is interesting. Let's look at the schematic. And at the schematic, we'll see that D1 makes a positive and a negative voltage for 2 15 volts regulators. So now I'm going to put in a new bridge, and then I'm going to carefully turn up the mains AC and then measure what is going on the 2 inputs and outputs of those regulators. I got a very good breakthrough with this unit after I changed the bridge rectifier in there. Here you see it in the middle of the picture. I mean, that is difficult to get out. God damn it. and you know, to get a new one into that hole, it's because you can't really hold it here, and then it's gonna drop down, and then it's annoying. But anyway, the problem is, of course, not the bridge rectifier. Okay, so with a thermal camera, you could get deceived by something on the power rail that is shorted in such a way that you have 0.0 ohms across it, and that means it's not going to be heated up, but it's going to short the power supply rails and then heat up the rectifier. But okay, the thermal camera got me into the right area of the problem. So what you see here between the 2 capacitors here, we got the 2 regulators for all the low voltage stuff, and because nothing was heated up by thermal camera and I really got a 0.0 ohm short, I was going for the regulators. So I took out the regulators and I still have a 0.0 short. So it actually turned out to be the 2 capacitors here, the 2 capacitors that's directly after the bridge. And they are indeed 0.0 ohms. I mean, how is that possible? I've been using a thermal camera for fault finding debugging for many, many years now, and I've never seen a capacitor like this going to 0.0 and not heating up just even a slightest, and they don't. So that is really crazy. So change those 2 capacitors if you got this problem with its eating fuses. The small fuse for, I think it's a 40 milliamps fuse. If your unit is just eating that, I mean, my first advice would be change those 2 capacitors and then see what happens. They're called C18 and C20, by the way, those 2 shorted capacitors. And look at that, it's very close to a very good short. I got good news and progress. We are now running at 230 volts mains voltage. And we got this red standby LED going on. And I set up my signal generator here. So all I have to do is click on the output here, and then I'll get a weak input signal. And then look what happens. It goes green, and you can hear this goes like ooh. And now I got 5.6 watts of idle, and that is of course because the mains transformer is now turned on via the relay. But what I have also done here is I have removed P5, as you can see up here. This is the transparent connector up there, right? So that connector is removed, because if I don't remove this, I got a pretty good short on the power supply. Here is my P5. So, and I've verified I got plus minus 75 volts unloaded. So that will be 68 loaded, obviously. So all this is good. By the way, yeah, that is the power on relay for the big bad power transformer, and that relay is kicked on by this capacitor and then held on by this resistor. And then there is a lot of logic up here with op amps and timers and all that kind of stuff. It's also monitoring a DC output, signal input and all that kind of stuff. And then it will pull this relay. But since all that kind of stuff is working, that's why I'm only worrying about this section. Oh yeah, this was the two capacitors that were shorted. And all this is now working perfectly fine. So this is the power amplifier section, and I need to know, where is the problem here? Why is this pulling 500 watts when P5 is connected? Oh, that is going to be funny. So here's what I did. I removed P5 and I soldered 3 wires on the power supply and connected it to an external power supply. And of course there is a bad short somewhere in the but it's not a short like that, because look, if I crank down the voltage a little bit, look at that, then there is no current usage. So 3 volts and then 4, and then it goes like that, right? So now, and then I can go back to 4. Yeah, so that is 2 times 4 watts. And of course I'm taking my thermal camera, and then I'm looking a little bit around, and of course I see all the emitter resistors light up, and that means all the transistors, they are activated. So why are they that? And there is let's get the macro on. There is a resistor down here, right left of the inductor. That one gets hot. So that little resistor right there is called R106, and then I will have to look a little bit again. So this is what I will do the next few hours, trying to figure out, where is it going? With a little bit of update, I've been playing around with this unit quite a while, and there is of course a very good explanation for R06 to be the one that gets hot, and that is because, you see, DC can never make this hot, and that is because this thing oscillates at full mega power, and then everything goes through the capacitors and then heats up this resistor. And it's actually 1.6 megahertz it's oscillating at. And I also see some modifications done to this inductor and this resistor and that kind of stuff. So maybe that is also what is causing this amplifier to oscillate. I don't see any kind of DC problems with all this kind of stuff. All those transistors work. I got all the right voltages, everything we're here, right? And if I short those resistors, all my DC and all my stuff goes away, and that means when voltages go up here, then currents gets up, and I mean all the expensive stuff, that is this, all this, the rest of this stuff is just peanuts compared to what this costs. So as long as this works, I mean, then there is probably a future for this amplifier. The reason why it is a little bit annoying to debug around those power transistors, that's because they're connected together with emitter resistors like that. So when you DC measure in the circuit here and you think you're measuring this transistor, you're actually also measuring that transistor, right? So this emitter resistor up here looks like it's a lot different than the others. It looks like it was very, very warm. And also, there's some evidence that somebody before me was soldering around in this area, like disconnecting that transistor. And I believe that is a clue because I think that is where the problem is. Oh, yeah, let's try that. So that was a little bit of progress. Yes, the emitter resistor here is out. And that emitter resistor is indeed working. It was supposed to be 0.47. So that is okay. So what I did is I disconnected the transistor here. Well, I didn't really do it most beautiful. I'm so sorry about that, but I only need 2 of them to be disconnected. And then, yeah, I can see this transistor is definitely not good. And you know what? Look at that. Here is a connection on the emitter resistor side. So that transistor is definitely that one. And that is doing the bias feedback on that side, right? And this, of course, is going to create instability in the circuit, and that is why it is not working. So it is time to stop this video, because I don't have any spare parts for this, and I don't know if we're going to buy spare parts, because those transistors are quite expensive and hard to get, and I don't know if that is within this scope of what I wanted to achieve with this particular unit. So yeah, I will call it a day and pack it nicely away for a future project, maybe. You never know.